Hi, today we're going to continue working with logarithms, and we're going to be using laws of logarithms to be able to expand or condense expressions that contain logs in them. And I want to remind you that a log is an exponent. So I'll review the rules, and keep in mind it's the rules that you would normally do with exponents. So rule number 1 is the product rule, first law. All right, basically this is saying that, remember, logs are exponents, so you're adding exponents when you're multiplying bases. That's what that's saying. Second law, or quotient rule, you're subtracting exponents when you're dividing like bases. That's what that rule is. And the third rule is you multiply the power to the exponent when you raise an exponent to a power. So that's the third law. All right, and that's it. There are only 3 of them, so we're going to be using only 1, 2, or 3. So problem number 1, we'll use the first law, then we'll use the second law and the third law, and then we'll put it all together. So on the first law, we want to condense it. That means to make it into a single term or as little terms as possible. Well, we have a log being added to a log, and they're like bases. So again, if I have a log being added with a log, I can condense it by taking the 2 pieces after the logs and multiplying them. So this will condense to log base 2, and then I take the x piece and the y piece and I multiply them. Okay, can go the other way around as well. So the log base 4 of 3x. Well, these 2 guys are being multiplied. So if I want to expand it and separate out the logs, I know that when I multiply with exponents, I can add them together. So that would look like this. Log base 4 of the 3 plus log base 4 with the x. All right, second law, the quotient or second law, quotient rule. When you are subtracting exponents, it means that you originally were dividing the like bases. So if I have a log minus a log, that basically means that I have an exponent being subtracted from an exponent, which means that we were originally dividing the 2. So you keep the log base 2, and then you do the x. First one always goes on top, and then the y on the bottom. Okay, expansion, same thing. If I want to separate example 2b, I have the exponents and 2 guys are being divided. That means I can separate them by subtracting them. So log base 4 of 3 minus log base 4 of x. Okay, and the last rule, the third rule, power rule. If you have a power on an exponent, it means you multiply. So for 3a, these 2 guys are being multiplied. So the 3 is being multiplied to the exponent. That means that originally that 3 was a power. So you have log base 4 of x, and you put the 3 back up here as the power. All right, or we can go the other way around. If we have 2 as the power and we need to expand it and get rid of that, the 2 power goes out here as multiplication. All right, so those are the only 3 rules you need to know, and now we're going to involve them like 2 or 3 of these rules all in a single problem. Okay, so problem number 1A, 1B, and 1C, we want to condense it. That means to put it all together as little as possible. I would recommend that you always look at the times first, and if you have a power rule that you're going to use, the third rule, I would do that first. So when you're condensing, I have a 2 out front being multiplied, and I also have a 3 out front being multiplied. So first, I'm going to put that power back using the third rule, putting it back up here. So then we have log x squared plus log y cubed. So I use the third law. Then I see that I have a plus sign here. That means I can condense it, because if I was adding exponents, it means I was multiplying them. So now I'm going to put them together by multiplying log times x squared times y cubed. And that's as far as we can go. So we use two laws, the first one and the third one. Okay, B. Again, anytime I see, when I'm condensing, I see a number out front of a log, I want to put that back first as the power. So I'm going to have log x minus log of y to the 1/2 power. Now, we don't normally keep it a 1/2 power now when we're condensing. We're going to actually change it back to using with a radical, because if there is a fraction in the power, we know that it involves radicals. So just simplifying this guy right here, a fraction means a radical. Y is the guy inside. This is the root number. It's 2, but we don't normally show a 2 there. And then the 1 power is right there, but we don't normally show that either. So that log y to the 1/2 really means log radical y. Okay, and then lastly, after we converted that, I am now going to take and use my second rule, which was my quotient rule. When I am subtracting two logs, it means that I was originally dividing if I'm subtracting exponents. So you put the log back, and then you do x divided by radical y. And that would be as small as you can go. Okay, so 1C looks really difficult, but again, there's only 3 rules. So let's do order of operations. Order of operations, I would want to first bring the powers back. And then I will take care of inside parentheses. So the power goes back on as x to the 1/2 power minus parenthesis log y to the 4th plus log, z. Okay, the next thing I'm going to do is I'm going to take care of this power and this, I'm going to take care of that power and get rid of the fraction now, and I'm going to do parentheses next. So log 2 still we're going to keep. X to the 1/2, well, we already talked about this. That means that there's a radical. X is underneath, the root is 2, and the power is 1, so I don't have to show those numbers. Minus, and then I put that together as a single log. And when I'm adding, I multiply them. So I take this y to the 4th and that z, and I multiply them. Okay, and then lastly, I'm going to do my order of operations left to right. These two are being added. That means they're being multiplied. So log, we have 2 times radical x. And then this guy, minus sign, means to divide. So that's going to be over y to the 4th z. Okay, that's condensing. Now we're going to use our rules to expand them. So 2a, first off, when you're doing expansion, you don't want to do the power first. First, I have to separate that because the 2 goes only with the x. So if you put the 2 out here right now, you're saying that the 2 goes to both items, and it doesn't. So we're going to have to expand this first. They're being timesed, so I separate them out by adding. Then I'm going to take care of the power, and the power goes outside. Now, some of you guys, after you get good at this, are actually going to be able to go right from the problem to the answer in one step. If you can see it, then you don't have to do multi-steps. All right, 2B. So again, some of you guys might actually see the exact answer right now, but I'm going to slow it down. First off, I definitely want to take care of that division and separate that. So it's going to be log of x. And I don't know, if you guys actually want to do the multiply now, we can take care of that. That's being multiplied, so I also know I'm going to separate that by addition. So log x plus log of y cubed. The division sign, I'm going to minus now log of radical z. Okay, then I'm going to take care of the 3 power. And that 3 power is going to go out here. I also have to take care of this radical. So I'm going to actually cross this off because a radical z is really a z to the power 1 square root means root 2. So if I change that, then I can put the 1/2 power in front. So now it's going to be log x plus 3 log y minus 1/2 log z. All right, and lastly, on problem 2C, we have a cube root on all of those guys. So in order to unravel this, I have to unravel that cube root symbol. So a cube root symbol, if you recall, I can distribute the cube root of 3 to both terms. So I have an x to a power 4, and I'm going to apply a root 3, so that will look like 4/3. And then the y, I have a power 1, and I'm going to apply a third root. That means divide 3. So that's the quickest way to bring that third root symbol in. Now I have times. So if I have times, I can separate it by addition. And then lastly, to bring the powers in front, the powers get put out in front by multiplication. And again, if you're able to go from the original problem to that in one step, which some of you guys will actually start being able to do, that is fine. All right, so those are the expansion and condensing rules. They go back and forth. The last type of question they might ask you to is to represent actual numerical logs with variables. So on this particular problem, we're going to be using log 2s and log 7s. And in place of a log 2, we're going to put an a. And then in place of a log 7, we're going to replace it with a b. And I'm going to stress this, you can only replace them with those letters when you actually have a log 2 or a log 7 showing. So problem 3a, I have a log 14. So right now, I don't see a 2 or a 7, so I don't have any letters. But remember, math we can manipulate. We know that 7 is actually the product of 2. We know that 14 is the product of 2 and 7. So I'm going to rewrite 14 as the product of the numbers 2 times 7. And then we learned that our laws, now again, at this point, we cannot replace an a and a b yet. This is a 2 and a 7. It is not a log 2. It is not a log 7 yet until we expand it. So I know that when I'm multiplying, I can separate them out by addition. So it's going to be the log of 2 plus the log of 7. Now that I actually separated them out, I can see a log 2. And if I see a log 2, I can replace that with an a. And if I see a log 7, I can replace that with a b. So my final answer will be a plus b. Problem 3b, I have log of 28. So somehow there's probably a way to use a 2 and a 7. Well, 28 is equal to 4 times 7, but then 4 is equal to 2 times 2. So 28 is really 2 times 2 times 7. So I have 3 guys being multiplied, but the rule expands out. So if anytime I'm multiplying, I can add. So I have the log of 2 plus the log of another 2 plus the log of 7. So I now can see an actual log 2. So the log 2's, I can now replace those with a's. And then the log 7, I can replace that with a b. So that's equal to a plus b, which we would just write then 2a plus b. Okay, the third one. Well, we actually see a 7 and a 2, but I want to stress we cannot replace it yet with an a and a b because we have to actually get log of 7 separated out. So we have a division, which means I can separate them out by taking the log of both, subtracting them. So log of 7 minus log of 2. I now see my logs separate. So here's my log 7. There's my log 7. I can replace that with a b. And then I have my log of 2, which I can replace with an a. So that will be b minus a. Okay, now log of 20. Okay, we have a 2 in there. No 7, that's okay. Log of 20, well, if I want to get a 2, it's going to be a 2. But then I have to do times 10. And then you're thinking, well, what can I do with that? Well, let's see. I'm going to separate them out. And I have a log of 2 plus a log of 10. All right, so little thing you also have to know. You can use the 2 and the 7 that they gave you letters for, and there's always a thing that's underlined that you also need to know. You can also use the base number. That's a given that you know that that's another option. If you remember logs, if there is no base number, the base number is 10. So no number there, base is 10. So you can actually use a 2, a 7, or a 10 in this problem. So we couldn't use the 7, we could use the 2, and then we actually could use the base number of 10. And here's why. The log of 2 is going to be written as an a, and if you're working with the base number, you know that that can actually simplify. The base is 10. That means what exponent makes a base 10 become a 10, and it's a 1. Now, if you don't know that, that's okay. If you're working with the base number, you can actually just put log 10, and that's why the answer is 1, because the exponent that makes a 10 is a 1. You can also use your other key for the 84. You would put a 10 and a 10. So again, this means what's the exponent that makes a 10, and it's a 1. So any of the base numbers will work because they will simplify. So log of 10 is 1, and that answer is a plus 1.